Hello, today we're going to have a quick intro to set theory. I think you'll find that it's pretty straightforward. Here we go. So first we have a question. What is a set? So it depends on who you ask, but for the purposes of this video, we're going to say that a set is a mathematical object that contains things which we will call elements. So a very popular and typical way to see a set represented is like this. So we have, here's an example. Set A is equal to 1, 2, 3. So the set we will call A, and when we refer to the set, really what we mean is this collection of elements. In this case, it's numbers. Now, a set could have shapes. It could have the states of United States. It could have city names. It could have anything in it that you desire. Now, there's a few things to note about sets. One, order doesn't matter. So what I mean by this is A is equal to 1, 2, 3 is equal to 1, 3, 2. These are all the same. 2, elements are not repeated. So what this means is A is equal to 1, 1, 2, 2, 3 is really, we don't repeat stuff. 1, 2, 3. And this is still A. So those are two rules about sets. Now let's look at how we can talk about them. Pause the video, take these notes if you need to. Okay. All right, here we go. So now we're going to talk about comparing sets to each other. So first you have set A is equal to 1, 2, 3. And we'll say set B is equal to 1, 2, 3. We'll say N, I guess. So actually, we don't even have to say that. We can just say dot, dot, dot. So we have two different kinds of sets here. This is a finite set because there are only 3 elements. And then we have an infinite set. This dot, dot, dot means it just goes on forever. If I would have finished it with this N, it still makes it a finite set. So by taking that away, it becomes an infinite set. And actually, infinite sets tend to be the most interesting ones that we work with in mathematics. So what can we say about these two sets? First, let's look at this. We're going to define something called, we're going to have some different operations. So first, I guess I'll number it. The element 1, right? Element 1 it is an element of A and B. So this is, you have your element 1, which is in both sets. This is how we say it. We say element of, and then this comma is used for and. Now there's a bunch of different ways you could write it. You could just write element of A and element of B. You could write it however you want. At the end of the day, writing in formal math notation like this, it becomes kind of an art, and every artist has their own preferred style. So just keep that in mind. Let's see here. We can say that A is a subset of B. In other words, A is a subset of B. And we can also define this as, here we go. Because, this is just shorthand for because, okay. A is a subset of B because for all X that are elements for all, so all of the elements that are in A, they're also in B. And so this is the definition of subset. Okay, so we have those two. Now we're going to talk about two things called union and intersection. So if we say that, I'll write the union of A and B is A union B. It's also apparently called A cup B sometimes, which is kind of interesting. I just learned that today, actually. But A union B is, so we look at it, so we have 1, 2, 3, union, 1, 2, 3, right? So you take the two sets, you union them together, and really what this means is you're combining all of the elements into one set. So we don't have repetition, remember that, so you're only going to see 1 once, you're going to see 2, 3, but then you're also, from this set, you're going to see 4, 5, 6, and so on. So what we find out is that, in this case at least, A union B is just equal to B. Okay, and we'll explain what two sets being equal to each other means at the very end here. So I got one more. Okay, the intersection of A and B is, so we say A intersect B, or A cap B, again, very interesting, is, I'm not going to write it out, but A, B, these two sets right here, right? And an intersection is, you can think of it as like a Venn diagram. So if this is A, and this is B, we're looking for right here. That's the intersection. The union would be everything in these two circles together. So we're looking for that, and well, A has 1, 2, 3, B has 1, 2, 3, and a bunch of other stuff. So this is all that they have in common. So what we have is A intersect B is equal to A. And so what this means, if we're using this image, is really, and we've shown this earlier by saying A is a subset of B, is this is B, and this is A, right here. I guess I'll write this. So A is a subset of B because all elements of A are elements of B. And because of that, we can see that A union B is going to be B, and A intersect B is just going to be A. So go ahead and pause it, take notes. We're going to just look at one thing real quickly. I'll go ahead and leave this visual up there. Oh, so if we say, let's have another function, C is equal to 3, 2, 1. Now remember, order doesn't matter, so what you can notice is that these two are equal, and you could sort of get that intuitively, but the formal definition is that if A is an element of, okay, we'll use a different letter, how about G? If A is a subset of G, and these both have to be true, and G is a subset of A, then we say that A is equal to G. There are a bunch of other things to know about sets, such as like infinite unions of sets, and there's a lot to know, and I think I'll probably cover that in another video. But this is an introduction to sets. Please subscribe, hit the notifications, and I'll see you in the next video.